So now in this video we're going to look at the light dependent resistor, also called a photoresistor. So it's basically like a fixed value resistor, except for it has a window on top so that light can fall on the resistive element. The more light that falls on it, the better it conducts. The less light that falls on it, the worse that it conducts. In fact, if you get the light bright enough, it's going to conduct almost freely. That's why I have a series resistor there. Their resistances will add up. We're using 5 volts, so I'm using a 220 ohm resistor to set the minimum current if this were conducting perfectly. Doesn't matter what order they are in. That's why they're in opposite orders there. So I also have an LED with no current flowing through it, just to kind of compare. And I'm going to cover the light dependent resistor with my finger. You can definitely see that LED got darker. If I kind of shade the lamp too, we can get it off completely. I could also just turn off the lamp, of course. The overhead light is energy saving. It hardly produces any light. I'll also grab a flashlight, and you can see as I get the light on there, you can definitely see the LED is still glowing. We're not really washing it out because it's getting brighter. So the blue LEDs work for this experiment a lot better than the red LEDs, because red LEDs don't show up as well. But in any case, it's really that simple when it comes to using the light dependent resistor just as a basic resistor. Normally you use it more as a sensor, as a voltage divider. We'll look at that in future videos because it's a little easier to control other circuitry with the voltage than with how much current is flowing through. But when it comes to LEDs, how bright they are depends on how much current is flowing through them. So they make for good demonstration circuits like this. So, hope you enjoyed. Make sure you check out one of the other videos. Thanks for watching.